Welcome back to the Kentucky Small Ruminant Masterclass. Today's lesson is going to be on interpreting forage quality reports, and I'm Jimmy Henning from the University of Kentucky. In order to get started on this, which is interpreting forage quality results, which can be a little bit abstract in terms of the terms we refer to and the fact that they may be not very well understood or known to you. The first thing I want you to do is visualize a plant cell and its components using the Freshen Up gum. And Freshen Up gum was a gum marketed in the 1980s or so that was marketed and sold on uniqueness, the fact that it had a liquid center. And so it had chewing gum around the outside, and then you would bite it and they would say you would get a burst of flavor. That liquid center, I want you to compare in your mind and as we go throughout this lesson to the cell contents, the middle of the cell, because that gum is a very good analogy to a cell. The outside, the chewing part, is the cell wall. The inside is the cell contents. So that liquid center is like our cell contents, which are 100% digestible. They are going to contain carbohydrates and protein in a myriad of forms in the plant. And it may be as little as 35% or as much as 50%, it may be more, of the total dry matter in your hay sample. The chewy outside is like the cell wall, somewhat digestible in the rumen. Chewing releases sugar like the digestion in the rumen does. And it may be 40 to 65% of dry matter. Lower numbers represent less mature forages, higher numbers more mature forages. More mature forages will have more cell wall. So, visualizing a plant cell and its digestibility, that liquid center or the cell contents is readily available. In other words, 100% digestible. The chewy outside, the total cell wall, which is the same as neutral detergent fiber. That's the first time we've introduced that term in this lesson. We will talk about that in a few moments in greater detail. Old fiber is like old gum and something that you don't want. It's lost its sweetness, at least in my analogy, and comparing that to the cell wall. Old cell wall or old fiber, mature fiber, has lost some or a lot of its digestibility and loses digestibility due to advanced maturity. Now, a good test starts with a good sample. A good sample represents the lot of hay being tested, and a lot of hay is from one field that is harvested and stored alike. We want to core those bales from the end of the bales, or the round side of a round bale, and we want to take 15 to 20 cores and composite those together and send that whole sample to the laboratory. We want to use a quality laboratory, in this case certified by the National Forage Testing Association, and the analysis we have on the right is from the Kentucky Department of Agriculture, which is an NIR, near-infrared reflectance spectroscopy laboratory, and we'll talk about that in just a moment. But they are a certified laboratory. Let's talk about the methods that a laboratory might use. The laboratory may use, and you may specify, that they use wet chemistry to analyze your sample. That means they're going to use direct methods to determine the components that are important to us to know in order to estimate quality. It's a slower method and more expensive and destructive in that it consumes the portion of the sample that they are actually processing with wet chemistry methods. Near-infrared reflectance spectroscopy, or NIR, sometimes abbreviated NIRS, is a method that uses near-infrared wavelengths of light to scan a sample and calibrate that with wet chemistry. And we use that to predict those components that are important to us. It's non-destructive, it's quick, and it's less expensive in that we can get many predictions or many values from just one scan. Very important to the accuracy of NIR is the fact that your sample type must be present in the calibration set that was used for that particular instrument. And labs have a way of knowing whether that is true or not as they scan your sample. And again, certified laboratories are going to predict samples accurately. So next I want to talk about understanding forage quality reports. And I learned a lot about this from operating a mobile testing laboratory, NIR testing laboratory at the University of Missouri. When I finished analyzing the sample and handing the results back to producers like you see here, I thought my job was done. In fact, my job was just starting. It was almost universal that their response was to look at the sheet and then hand it back to me and say, well, is it any good? So I want to work through an example and give you an idea of how to know if your hay or the hay you're trying to feed is, in fact, any good. But to understand reports, we've got to understand the relationship between fiber and energy. And I need to introduce a new term right here that we'll talk about again more later, and that's ADF, or acid detergent fiber. An acid detergent fiber is often generalized as being the indigestible fiber within that cell wall. So back to our freshen up gum example, that would be the gum that's left after you chewed it and the sweetness is gone. Okay, so that's ADF. This is a correlation between ADF, which is a laboratory measure, and TDN measured in either in vitro, which means in the laboratory, or using the fiber method that we've talked about. And you can see that in general, as ADF gets higher, TDN gets lower. This is one equation here that is generated from this data to predict TDN from ADF. And there are many equations to predict TDN. Some are based solely on acid detergent fiber, and others are more complex. And it's important to know the type of equation that your laboratory that you've chosen to send it to uses. If you need to know more about that, you can consult with us, or you can consult with your county agent, or with specialists in animal and food science at UK or at Kentucky State University. So now we're going to focus on those two main forage terms, NDF, neutral detergent fiber, and acid detergent fiber, or ADF. NDF is the total fiber in the plant, composed of cellulose, semicellulose, and lignin, used to predict intake. ADF, acid detergent fiber, is a subset of NDF. Obviously, it's a part of the fiber composed of cellulose and lignin and used to predict TDN, or energy. But as I said, the methods that are used to predict TDN, or energy, will vary. And it's really important to note, and this is as good a time as any, that we will measure things in the laboratory that really don't have direct ties to the animal. There's nothing about ADF that helps you understand how that relates to how to feed a sheep or a goat, or NDF for that matter. So we will have to use calculations then in order to do that. Let's take a look at breaking down the KDA report and what's on it. You've got your laboratory information in the header, sample information that you have provided or the grower has provided to the laboratory to identify the forage, and then at the bottom, the forage analysis. And we will use this forage analysis for most of the rest of this presentation. One of the first questions I get is, why do we have two columns in the data? Well, you'll notice the columns are titled as received and dry matter basis. The as received is where the component calculations are based on fresh weight when received by the lab. And it's important in this column to note that moisture content. That tells you a lot about the hay as it was sampled and sent to the lab. If that were to be above 20 and you know it's a hay sample, then you know that that hay when sampled was fairly wet. If it's below 15, then you know it's dry enough to be what we would call stable. The as received bases or values are seldom used, except if we're measuring out fresh forage in a ration. In that case, we need to know to account for the weight of the water in that fresh forage. So for our purposes, we're going to use the dry matter basis column to estimate and to compare forages. So we will nearly always just look at that dry matter basis number. I did want to show you a more complex report. This one is from Dairy One, also a certified laboratory. And Dairy One uses a different terminology for that as received column. They call it as fed, but it's the same thing. It's the calculations are based on the fresh weight as received by the laboratory. I'm going to start with the most important value on that sheet, and you may disagree if you've tested hay before, but I'm going to say total digestible nutrients, or TDN, is the most important value on the report. And I've highlighted the TDN in the report, and you'll notice that it says it's 50%. TDN is a calculated estimate of the digestibility or energy content of the forage. TDN goes down, as you've seen, as ADF goes up when forages become more mature. TDN is the most important number on the report in my view because energy is the most limiting nutrient in forage diet. So I want to challenge you when you get a report to look past crude protein and look at TDN, because more times than not, the protein will be adequate, but the energy or the TDN value will not be for what you need to do with your sheep or goats. So we've talked a little bit about protein and how that's intuitively understood, but let's look a little further. This particular sample is 12.38% crude protein on a dry matter basis. So crude protein is not an actual measure of real protein, but an estimate of protein in a forage. We calculate by measuring nitrogen and multiplying by 6.25. We get that factor because that's approximately the proportion of nitrogen to total weight of protein in real protein. Crude protein combines real protein and non-protein nitrogen like nitrates in the estimate. Forage diets will be limited by energy before they are limited by protein. I want to talk about relative feed value because it's an index of quality for comparing similar forages. And it's probably 40 years old or so in use, or it was developed to provide a one number value for comparing forages. And it's important to note that we can only compare similar forages with relative feed value. In this case, the relative feed value of this clover grass sample was 88.93, which was probably, as clover grass samples go, not very high. So remember that number. Remember 90 as the relative feed value for this sample. We will have a table at the end that we will just look at and try to place this sample as being high, medium, or low quality. So RFV is an index for ranking cool season grass and legume forages based on combining digestibility and intake potential. And we do that from calculating the digestibility estimate and the intake estimate from ADF and NDF. The higher the RFV, the better the quality. The RFV of full bloom alfalfa was set to about 100. And now let's come to the fiber numbers themselves. NDF, neutral detergent fiber, is that total fiber in the forage. And in this sample, it's 58.73. As we said, it's composed of cellulose, hemicellulose, lignin, and ash. Used to estimate intake, low NDF numbers are desired. Low NDF values indicate livestock can consume more of a forage, and low NDF values come from less mature forages. Now ADF, or acid detergent fiber, which we have said is the relatively indigestible fiber in that plant cell wall or that freshen up gum that you have chewed until the sweetness is gone. And in this case, the acid detergent fiber is 42%. ADF is cellulose, lignin, and silica. It's used to calculate TDN, correlated with energy in a negative way in that high ADF means low energy. So low ADF numbers are desired. Low ADF values come from less mature forages. And here's a table that can help us then to rank those forages. And I ask you to remember the RFV of 90 for our clover grass sample. So on our, it's a mixed sample, and it's an RFV of 90, which places it in the low range of the medium category, where I've arbitrarily set up these values to set up to rankings of hays of different kinds into high, medium, and low. And this serves as a very quick and I will say crude method of separating out whether or not a forage is high, medium, or low. I know, for example, that the TDN diet in diets of sheep and goats needs to be about 58% or better for almost every class of sheep and goat that I was looking at. I was looking at does and ewes with twin lambs, either at all stages of gestation and lactation, and also at maintenance. And they start at 58%. So, and I've made in this table that high quality hay starts at 58% TDN. So you can see that we're going to need to know something about the requirements of the animal to really estimate the performance of or how good a hay is. And of course, the best way to gauge quality is the actual animal performance. Rations like the Langston Interactive Nutrient Calculator, abbreviated LINC or LINC, are going to require a lot of information from you. They're going to require information about the type of animal that you're inquiring about. They're going to need to know things like the breed, or if it's a dairy goat or a fiber goat, or things about that goat type. And they're going to want to know, what are you going to try or need to feed to that animal in order to meet their needs? And the last thing you'll need to know is, does it have access to pasture while you're feeding this hay? So in summary, in order to interpret a forage test, we got to start with a good one. And to get a good forage test, we need a good sample with 15 to 20 cores for each lot of hay that's representative. And that sample is composited and sent to a reputable laboratory. To interpret those results, we need to focus on TDN. And I've already said that TDN, in my opinion, is the most important value on the report, and crude protein, and compare those values, which are calculated, to the nutrient needs of the sheep or goat that you're looking at, trying to feed, and their stage of production. And we may use a ration calculator like the one from Langston University, abbreviated LINC. And remember, the best indicator, the best measure of forage quality is actual animal performance. Thank you for your attention in this module. And we do want to thank our sponsors for their support of this small ruminant masterclass series.